Good afternoon, everybody. My name is Worawith Sangkatip and Jiratta Phuboon-ob. We come from Research Center of Information Technology for the Future, Department of Information Technology, Faculty of Informatics, Mahasarakham University, Thailand. To start, I will describe first, introduction, second, research problem, third, research contribution, 4, related works, 5, methodology, 6, datasets, and data preprocessing, 7, evaluate measure. After that, we will consider experimental setup and experimental result. Finally, we will conclude my presentation. Introduction: Non-communicable disease (NCD). NCD are not transmissible directly from one person to another. World Health Organization (WHO) report that NCD caused 41 million deaths each year, according to 71% of deaths in the world. In Thailand, NCD caused several deaths, especially for persons who are over 30 years old. Research problem: NCD patient away has multi-morbidity. For example, diabetic patients usually have hypertension symptoms. Classification: not NCD disease on patients who diagnosed with multiple illness. Research contribution: first, to classify NCD disease on patients who diagnosed with multiple illness. Second, challenging issue in multi-level classification research. Third, results provide predictive algorithm with the highest level of accuracy for the multiple NCD patient. Related work: Bachelor is or published in 2012 define three categories of methods for multi-level learning as follows. First, algorithm adaptation method. Second, problem transformation method. And ensemble methods. Related work for disease diagnosis domain. Author 1. Lee is all published 2016. Proposed a multi-level problem transformation joint classification datasets, physical examinatory records, 110,300. Three diseases include diabetes, hypertension, and fatty liver. Continue public 2017. Proposed a novel ensemble label power set pool dataset joint decomposition focus 3 chronic disease. Author 3. Zhang is all public 2019. Proposed a novel deep neural network model for multi-level chronic disease predicts datasets T chronic disease. Methodology: the research work is processed in multi-level classification by using four methods as follows. Method first, binary level BR. Second method, classifier chain CC. Third method, the random k-level sets like Q. And methods, multi-level k-nearest neighbor MLKNN. The VR, CC, and LAKEL are defined to use basic classification algorithm with each algorithm random forest, while MLKN use candidate neighbor algorithm classification process shown in figure or slide. Dataset. Dataset collects the electronic health record from Worawith Hospital as Sangkatip province. Data for these experiments was 19,554 medical examination collected during 2014 until 2019. Research the focus flow disease, diabetes disease, hypertension disease, cardiovascular disease, and stroke disease. Data Preprocessing. The datasets are composed with the two tables according to NCD screen and diagnosis OPD. NCD screen records the information from the patient. Diagnosis OPD is a table collect from the diagnosis result patient who use the medical service. Data preprocessing. Next, data integration is performed. This is to combine to the table schema. We select only the diag type attribute, add the diagnostic type, and the diag code reference to the ICD-10 GM disease code. Then we filter the data to select only for the NCD, diabetes, hypertension, cardiovascular, stroke. Data preprocessing continue. The attributes are classified into 13 groups and data types are demonstrated in table on slide. The final summary of the dataset used in the experiments instance total is 19,554. Filter is 13, label is 4, label set is 15, label cardinality is 0.151, label density is 0.0Tx. Evaluation measure accuracy and Hamming loss. Equation is shown in slide. Experimental setup. This research experiment which process in multi-level classification by using flow methods as follows: BR, CC, Lakel, ML, KNN. Parameters are determined by using the follow algorithm. BR and CC do not provide the parameter value. Like algorithm, the number of label is subset K is 3. The number of subset M is 10. ML algorithm, the number of nearest K is 3. The parameter in a random forest classification algorithm number of tree num3 is 1000. The maximum depth of the tree is 0 for limited depth. 2. The number of attributes in random select is 0. Experimental setup. The tool is Mega software with its attention of the Vega program. We are used in VRCC Lakel method. ML KNN method use Boolean frameworks. Average model with tenfold cross verification, average measure, accuracy, and Hamming loss. Experiment result. The experiment will set up using the flow multi-label classification method to learn the gift dataset. The efficiency is method-based measure my accuracy and Hamming loss, which has been shown in the table. The explanation are as follows. First, BR method result 84.37% of accuracy rate. Hamming loss value is 0.0504. Second, CC method provide 89.96% of accuracy rate. Hamming loss value is 0.0377. Third, Lakel method outcome 91.07% of accuracy rate. Hamming loss is 0.0377. 4. MLKN method has accuracy rate 72.10%. Hamming loss is 0.0874. The results show the Lakel method gives the highest efficiency considered by accuracy value, which is 91.07 accuracy percent of accuracy for him loss. Both Lakel and CC obtained the result of marginal loss close to zero. Conclusion and future work. The Lakel method is the most effective method with an accuracy rate 91.07%, the highest rate compared with the authority method. Future work is developed measurable classification method using deep learning algorithm for NCD data, which is achieve higher accuracy. Acknowledgement. This research is support Sutaweth Hospital, Faculty of Medicine, Mahasarakham University, who provide the NCD screen data. Thank you for your attention. Are any question? Thank you very much.